Hello, welcome to my YouTube channel. My name is Nathaniel, and I welcome you all to Best Grade Services. So today we are going to look at linear programming models, part two. We already looked at the part one, so if you've not watched the part one, what I'm going to do is I'm going to put the YouTube link in the comment section, so you can just click on the link, then you watch and enjoy the content, right? So in the part one, what we did was to learn how to formulate and solve linear optimization model. But in this session, what we are going to do, again, we are going to learn how to formulate and solve linear optimization model. But in this form, in this series, what we are going to do is we are going to learn how to formulate and solve it given a word problem format. Also, we will learn how to formulate and solve linear optimization level using Excel. Great. So quickly, let's look at this word problem, simple word problem here. It reads, ABC Limited produces Sony and Cello products. Manufacturing requires the services of the IT department and the marketing department. The IT department has 15 skilled workers, each of whom works 7 hours per day. The marketing department has 4 workers who also work a 7 hour shift. Each Sony product requires 3.5 labor hours in the IT department and 1 labor hour in the marketing. The Cello product requires 4 labor hours in IT and 1.5 labor hours in marketing. The company operates 5 days per week. ABC makes a net profit of $50 on the Sony model and $65 on the Cello model. The number of Sony products must be at least twice the number of Cello products. The company wants to determine how many of each model should be produced on a daily basis to maximize net profit. So let's begin. So you remember from our last series, we learned how to formulate and solve linear programming models. And we found out the steps in doing so. So the first step for us to do, so the step one, in order to formulate and solve a linear programming model or linear optimization model, the step one, you have to identify the decision variables. And we found out that the decision variables are the unknown variables that the question seeks to obtain. Great. So when we look at this example, it reads ABC Limited produces Sony and Cello products. So they produce Sony and Cello products. But what we don't know is what quantity of Sony product they produce, the quantity of Cello products they produce. So the unknown variables here are Sony and Cello. So now our unknown product here will be Sony, which I will represent as X, and Cello, which I will represent as what? Y. But now, what is the step two? Step two from our previous episode is that we should be able to identify our objective, should identify our objective function. So now, what did we say the objective function is? We said the objective function is the focus function, is the function that the question seeks to optimize. So really, the optimization is we are looking out for how much or the quantity of each product that the company will use in order to either minimize or maximize profit and cost respectively. Right. Great. So here, let's read and identify our objective function. So I'm going to read from this part. It is that ABC makes a net profit of $50 on Sony model and $65 on the cello model. The number of Sony products must be at least twice the number of cello products. The company wants to determine how many of each model should be produced on a daily basis to maximize net profit. So now the objective function is they are finding ways to maximize their net profit. So our objective function will be the maximize max of the net profit will be equal to. So what do we see here? These are ABC for them to be able to maximize. So we are trying to look at, they've been giving us the net profits here. So we are looking at how to maximize this net profit. So that is our objective function. So ABC makes a net profit of 50 on Sony. So that would be 50 multiplied by the Sony, which we represent by X, plus 5 multiplied by our cello, which we represented by what? Y. So we are looking out for ways to maximize this net profit. So this is our objective function. Great. And then step 3, which is the final step, is for us to identify all our constraint functions. Great. And during our last series, found out that the constraint function is the function with limitation. Good. So now let's read the question and see how to identify our constraint function. So it says ABC Limited produces Sony and Cello. These are our decision variables. So manufacturing requires the services of IT department and the marketing department. So now the IT department has 15 workers, each of whom works 7 hours per day. So what do we see here? So the 15 workers are limited to 7 hours each per day. So that means that each worker is expected to work 7 hours. They cannot exceed 7 hours. So they are just limited with what 7 hours. Good. So now what we are supposed to do here, let's separate it because the firm has two manufacturing department. They have the IT department and they have what the marketing department. So I'm going to separate this. So let's look at the department. We have the IT. I'll bring the, let me go back and just give two spaces here and say this is the marketing department. Good. Good. So let's follow. So what we are going to do, let's read the question here. It says that the IT department has 15 skilled workers. So the total number of skilled workers. So let's look at the number of skilled workers equals 15. But let's read. Each of whom works 7 hours per day. The number of work hours. So let's say the number of hours worked a day. A day is 7 hours each. But so what do we see here? So what will be the total number of hours worked per day? So the total number of hours worked per day to the total number of hours worked a day will be equal to the number of workers, which is 15, multiplied by the number of hours worked per day. So times 7. And this will be equal to 105 hours. Good. Hope you're all following. We are done with the IT department. So now let's go to the marketing department. Said the marketing department has 4 workers. So the number of skilled workers in the marketing department, number of skilled workers. Let me just do number of workers. Yeah. Number of skilled workers in market marketing department is what? 4. Good. And they are saying here who also work a 7-hour shift. So the number of hours worked per day, right? So the number of hours worked a day will also be 7. So the total number of hours worked will be will be the number of workers multiplied by the number of hours worked. That will be 4 multiplied by 7, and that should give us 28. Good. So now let's see how we are going to get all our constraints. So let's learn how to get all our constraints. Let's continue reading. So let's find the constraint now. The constraints. Then we are going to do that for the IT. Same we are going to do for marketing. So let's look at IT. Let's continue. Say each Sony product requires 3.5 labor hour in the IT department and 1 labor hour in marketing department. So now IT department requires what 3.5 labor hours. So they say each Sony product. So the Sony product requires what 3.5 labor hours. So now 3.5 multiplied by Sony, which represented by what? X. Multiplied by X. So each Sony product requires 3.5 labor hours in the IT department. So this is the IT department, and 1 labor hour in marketing department. So when we see the marketing department, they require 1 labor hour of what Sony products. So let's look at the marketing department. So the marketing department requires 1 labor hour. So 1 multiplied by X. Let's continue. The cello product requires 4 labor hours in the IT department. Again, plus 4 multiplied by Y. Cello was represented by Y. And 1.5 labor hours in the marketing department. So plus in the marketing department will be 1.5 multiplied by what? Y. Now, in the IT department, they are not supposed to work to exceed 105 hours from our computation. So this should be less than or equal to 105. Good. And this should be less than or equal to 28. So we've gotten our 2 constraints. So let's read and see if we can find any additional constraint. Good. So they said the company operates 5 days per week. ABC makes a net profit of 50 on Sony and 65 on Cello model. The number of Sony products must be at least twice the number of Cello products. So now we found another constraint, and this constraint is called the mixed constraint. So let's write our mixed constraint here. And our mixed constraint says that the number of Sony X must be at least means greater than or equal to, right? Must be at least, so greater than or equal to twice the number of cello. And what is cello? Cello is Y, right? So twice the number of cello to multiply by Y. Or I write it as minus 2Y plus X to be greater than plus X, and we just give some space. Plus X should be greater than or equal to 0. So you can write it like this. or we can write it like that. Good. So what then do we do? The next thing is for us to write our non-negativity constraint. The question says that how many of each model should be produced on daily basis to maximize the net profit. So we are looking at the positive, the values on the positive quadrant, right? That's the positive value. So we are looking at for non-negativity constraints. So our non-negativity constraint will be x, y greater than or equal to 0. So this will be our non-negativity constraint. Great. So having found all the constraints and the objective function, let's move forward and see how to find the optimization value. So what I'll do here right now is to stop sharing. So first, let's use Excel. Let's learn how to use Excel to find the optimization value. Then we will use solve it manually to see if our answers match. Right. Good. So let's use Excel. I'll bring my Excel up. I'll bring my Excel up just a second. Good. So I have my Excel here. I have my Excel here. So I'll bring that here. Since we have all the models here. Good. Perfect. Have our constraints. So now on the Excel, what we will do is that we are going to use the solver to find the optimum value and the optimum points. Great. So what you have to do first is to see if you have the solver add-ins installed on your Excel. So for you to find that, you go to data at the top button, and at the far right, you check if you have this. If you don't have it, what you have to do is to go to file, you go to your options. Great. So in the options button, what you have to look for is add-ins. So you click on add-ins. Good. Then you have to look for solver add-ins. So if you don't have it, look for solver add-in. You click on OK. You click on it, then you click on OK, and that would install your solver. Great. So now the same thing as we've done on this worksheet, we are going to input all these values on our Excel. Then we use our solver to find our objective value and our optimum point. Great. Sorry, our optimum value and our optimum points. So now, step-by-step approach. First, we are supposed to identify our decision variables. So I'm going to name this cell my decision variable. And our decision variables were Sunny X and Cello Y. So in doing this, we always set our decision variables to 0. So Sunny will be 0, enter, Cello 0, enter. Good. What's the next thing for us to do? The next thing is to identify our objective function. So I'm going to put my objective function here, right? So I'm going to name this cell my objective function. Enter. And our objective function was the maximum net profit. So I'm going to say this is my max net, and that was equal to So in order to do any mathematical thing on Excel, you start with the equal sign. So that is equals 50 multiplied by X. That's Sony. So I'll click on the X plus 65 multiplied by Y. So I'm going to click on Y. Then I hit on enter. So I have my objective function here. What's the next thing to do? The next thing for us to do is to identify our constraints. So I'm going to put all our constraints in the Excel sheet open here. So let me name here my constraints. Right. So how many constraints do we have? We have one, we have two, we have three, we have three constraints, right? So when we add our non-negative constraints, then we have how many constraints? We have five constraints. One, two, three, four, five. So say we have five constraints. So one, two, three, four, and five. Good. So now what is our constraint one? Our constraint one says that it's 3.5 multiplied by x. That's Sony plus 4 multiplied by y. Enter, and that should be less than or equal to 105. So less than or equal to. So I'll name this side my inequality. Sorry. So I'll name this side my inequality. That's the symbols, right? Inequality. Then I'll name here my right hand side, which will contain the constraint. So let me say this is my left hand side. Left hand side. Yeah. Should be less than or equal to 105. Enter. Good. What's our constraint 2? That is 1 multiplied by x. That's Sony. So that's just going to be my x, the equal sign, then my x plus 1.5 multiplied by my y. That's cello. Enter. And that one is also supposed to be less than or equal to 28. So I'll put my constraint here, 28. Good. Hope you are following. Now, let me put in my mixed constraint. So I'm going to input this one. So my mixed constraint was 2. That's equals minus 2 multiplied by my y, which is cello, plus my Sony. Enter. That one was greater than or equal to 0. Good. So let's put in our non-negativity constraint. So it was our cello, that is x, should be, you press on the enter, greater than or equal to 0. Enter. Then my y, equal sign, enter, greater than or equal to, enter. That should be equal to 0. Good. So now I've fed my Excel with the decision variables, the objective function, and the constraint functions. Good. So what we are supposed to do now is to head on to the top right, click on the solver. So what we are going to do is to first reset the solver parameters. Click on OK, reset, and click on OK. Good. So it is said set objective. So in the set objective button, we are going to put our objective function here. So you click on our objective function, and that is it here. And in our by changing variable cells, we are going to put in our decision variables. So you hold the control, tap on X and Y, and that is it installed here. Good. Then we have subject to constraints. We are going to put in all our constraints. So we click on it, then we go to add. So you have to watch it because probably you don't want to miss any of the constraints, right? Or you don't want to enter them twice. So one, so cell reference, I'm going to put my constraint one. I click on it, should be less than or equal to, say the inequality sign is correct. Then I click on the constraint, which is 105. Then I click on what add. Good. So I'm on two. Cell reference, that's the one on my left hand side. I click on it, look at the sign, it's correct. So I move to the constraint. Then I click on the constraint, which is 28, add. Okay. So three, my cell reference will be my left hand side. I click on it. Now the sign here is greater than or equal to, so I choose on the arrow pointing down. I click on it, choose greater than or equal to. Then it is equal to 0. The constraint add. Wait, my non-negativity, that's number 4. Click on it. So the sign is wrong, so I choose greater than or equal to. Then that's 0. I add. Good. Then number 5. Yes. Good. The sign is wrong, greater than or equal to. That's 0. Then now I'm going to click on OK. So now I have all my objective functions. I have my constraint functions. Now, what are we supposed to do? Since we are doing simple linear programming models, what we are going to do is you have here select the solving method, click on the drop down arrow, then click on simplex LP. Then you click on solve. Good. Since I'm using two screens top here, so this pop-up appears, then you click on OK. Good. So now you see there is a change in our Excel sheet. So now it has given us the optimum points. So now they are saying that the firm ABC needs 28, needs to produce 28 Sony products and produce zero or zero cello products in order to maximize their profit. So for them to be able to maximize their net profit, then they need just the 8 Sony products and they don't have to produce any of cello products. So these are the optimum points, and this is our objective net profit. That is the optimum net profit that the company seeks to achieve. So this is very simple using the Excel. Great. So what we are going to do right now is we would solve it manually and see if our answers matches. Great. So now we are done with the Excel. So I'll move the Excel, stop sharing, then I'll share my whiteboard. Okay. Good. So let's start writing. So what I'm going to do right now is to write all our objective function, our constraint function from what we did. So we had our objective function. So I'm going to for objective function, it was then max net equal to 50x, which was Sony, plus 65y, which was cello. Good. Then our constraints. So our constraints. We had IT and we had the constraint for IT to be just watching from the other screen. We had a constraint for IT to be 3.5 by the cello multiplied by cello, which was x, plus 4 multiplied by, sorry, 3.5 multiplied by Sony X and 4 multiplied by Cello, which is Y, should be less than or equal to 105. Good. Then in the marketing department, we had X plus 1.5 Cello should be less than or equal to 28. Good. Then we had our mixed constraint. We have had our mixed constraint, and that was minus y plus x will be greater than or equal to 0. Now, and lastly, our non-negativity constraint, that was x, comma y, to be greater than or equal to 0, is our non-negativity. Since we are finding, sorry, our non-negativity, since you are finding the maximum, this will be our non-negativity. Great. So now that we have all our constraints, all our functions here, let's head on to find the optimum value and the optimum point. Good. So now let's find the interceptions first, because remember from our last episode we learned how to solve these kind of questions here. So given this, we are going to use it to find our optimum point and optimum value. So remember from last series, what we did was we first found the interception. So when we take the IT department, say the IT department, we are looking at x intercept. So at x intercept, y is equal to 0. That means that wherever we see y in the IT department, we are going to put 0. So we are going to get 3.5 x plus 4 multiplied by 0 should be less than or equal to 105. Good. And then we are going to get 3.5 x should be less than or equal to 105. So when you divide both sides by 3.5, divide both sides by 3.5, you are going to get x should be less than or equal to 30. Good. Now let's go to the next thing. So we are going to look at for the, we are still at the IT department, but here we are going to look at y-intercept. So at y-intercept, x should be equal to 0. So we are going to get 3 multiplied by 0 plus 4 multiplied by y should be less than or equal to 105. So we are going to get 4y should be less than or equal to 105. Divide by 4, divide by 4. Sorry. And that should give us, so this one cancels off the 4, and this one should give us 26.5. So we are going to get, so let me wipe it so that I create a space. Good. Hope you are all following. Don't forget to like, subscribe so that others would also benefit from this content. So we are going to get 4y should be less than or equal to 105. So we are going to get y to be less than or equal to 26.25 after dividing both sides by 4. Good. So now that we are done with the IT department, what we are going to do is to do that for the marketing department. So in the marketing department, let's look out for the equation for the marketing department. We had x plus 1.5 y should be less than or equal to 28. So in the marketing department, at x-intercept 2, y is equal to 0. We are going to get x to be less than or equal to 28. Good. So let's look at y-intercept. The y-intercept, x is equal to 0. So wherever we see x, we put 0. So we are going to get 1.5 y less than or equal to 28. So when we divide both sides by 1.5, we are going to get y to be equal to 18 point, sorry, it's 18. We're going to get 18.66667. I usually like 4 decimal places. Great. So now we found all the interceptions. Okay. So now what we are supposed to do is to create a table. So I like creating a table. So I have my table here, and then I'll name here X Sony, Y Cello, and now my maximum profit, I'm going to name it Z. So say my maximum profit Z is equal to 50X plus 65Y. This is what we got. Great. So now I'm going to use the equation we got from the marketing department, right? Another person can also use the equation we had from the IT department, and you are going to end up getting the same decision points, right? The points are going to be the same. Okay, great. So now I'm taking that of the marketing department, and in the marketing department at x-intercept, y is 0, and x is 28. Good. Then at y-intercept, x is 0 and y is equal to 18.6667. Y-intercept x is 0 and this is equal to 18.6667. So let me just create a space for it. Sorry. We had 18.6667. 18.6667. Good. So let me draw my line here. So now let's identify the optimum point, and the we are going to identify the optimum point and the optimum value. That's the optimization value. So now let's put these values in the objective function. So when x is 28, so what are we going to get? Y is 0. So we are going to get z equals 50 multiplied by 28 plus 65 multiplied by 0. And so 50 multiplied by 28 will give us 1,400. Here, good. Then now, when x is 0, so you're going to get 50 multiplied by 0 plus 65 multiplied by 18.6667 multiplied by this. So 65, that will be equal to 65 multiplied by that will give us 1,213.3355. So I always like 4 decimal places. So we are going to write here 1,213.3355. So now I don't need this. So let me just take this one off. Let me take this one off here. Forget the handwriting. So now, when we look at the table, what do we see here? You can see the objective function, that's the optimal point or the optimum value is 1400. And I'll show you in the Excel. So now let me bring in my Excel for us to compare. So let's compare this. So now, let me reduce this a bit. 100. Good. Good. So now, what do we see here? We can see that our optimum value or optimum point is 1400, and you can see the same in the Excel sheet. And now, what do we see again? And see our optimum values, that is 28 and 0. That is our decision variable. So that means that the firm is supposed to produce only 28 Sony products in order for them to maximize their profit. So you see in the Excel, we had the same thing. Great. So this ends our lecture for today. Don't forget to subscribe, like, and share for others to enjoy this amazing content. My name is Nathaniel, and welcome to Best Grade Services. Thank you. Bye. See you on the next talk. Bye.